second problem is once again using the principle of finite mathematical induction prove that. Now the statement is using the principle of finite mathematical induction prove that 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on up to n terms is equals to n terms is equals n into n plus 1 whole square into n plus 2 by 12 for all n belongs to n. For all n belongs to n. Solution. Let S of n be the statement. Before that, we have to find the nth term of the given series. ఇచ్చిన సిరీస్కి ఎన్నవ పదాన్ని ముందుగా ఫైండ్ అవుట్ చేయాలి. nth term of the given series. If we observe the first three terms in the given series, first term is only 1 square, second term is 1 square plus 2 square, third term is 1 square plus 2 square plus 3 square. In that sense, the nth term is 1 square plus 2 square plus 3 square plus so on plus up to n square. 1 square plus 2 square plus 3 square, third term. Second term 1 square plus 2 square, first term only 1 square, then the nth term is 1 square plus 2 square plus so on plus n square, which is the representation of sum of the squares of the first n natural numbers. Sum of the squares of the first n natural numbers, 1 2 3 so on n, they are called first n natural numbers. మొదటి n సహజ సంఖ్యల వర్గాల మొత్తము. The formula is n into n plus 1 into 2n plus 1 by 6. మొదటి n సహజ సంఖ్యల వర్గాల మొత్తానికి formula n into n plus 1 into 2n plus 1 by 6. Now we can substitute this one in place of 1 square plus 2 square plus so on plus n square. యాక్చువల్గా nth టర్మ్ అనేది ఈ వాల్యూ అవుతుంది, కానీ దీని ప్లేస్లో మనం ఇప్పుడు ఈ సూత్రాన్ని ఉపయోగించి ప్రతిక్షేపించుకోవచ్చు. సో దట్ ఈజ్ 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on plus, now we can write n into n plus 1 into 2n plus 1 by 6, which is the given statement. Let me consider it as S of n. ఇది ఇప్పుడు ఇచ్చిన స్టేట్మెంట్ అవుతుంది. దీన్ని మనం S of n గా కన్సిడర్ చేసుకున్నట్లయితే S of n is equals to, from the given statement, n into RHS value, n into n plus 1 whole square into n plus 2 by 12. nth టర్మ్ని ఎన్నవ పదాన్ని ప్రతిక్షేపించి S of n ని రాసినట్లయితే, ఇచ్చిన ప్రవచనాన్ని S of n అనుకున్నట్లయితే ఈ విధంగా ఉంటుంది. దీన్ని మనం ప్రూవ్ చేయడానికి once again we use the same 3 steps. First, step 1, we have to show or we have to prove S of n is true for n is equals to 1. n is equals 1 కి S of n అనేది నిజమని చూపాలి. సో LHS of S of n is equals to 1. S of 1. LHS of S of 1. So put n is equals 1 on LHS of the given statement. ఇచ్చిన స్టేట్మెంట్లో LHSలో n is equals to 1 ప్రతిక్షేపించినట్లయితే 1 into 1 plus 1 into 2 into 1, 2 plus 1 by 6, 1 into 2 into 3 by 6, 1 into 2 into 3, 6 by 6, that is 1. Next, RHS of equation 1, sorry, RHS of S of 1, RHS of S of 1, RHS, what we have, n into n plus 1 whole square. So once again substitute n is equals 1 on RHS of the given statement. ఇచ్చిన స్టేట్మెంట్లో RHSలో n is equals 1 ప్రతిక్షేపించగా 1 into 1 plus 1 whole square into n plus 2, 1 plus 2 by 12 is equals 1 into 1 plus 1, 2, 2 square, 4, 1 plus 2, 3 by 12, 4 into 3 into 1, 12 by 12, which is also equals to 1. Since LHS is equals to RHS, LHS is equals to RHS, S of n is true for n is equals to 1. Next, step 2. Step 2 is assumption, inductive hypothesis or assumption. We assume that S of n is true for n is equals to k. స్టెప్ 2లో ఏమని కన్సిడర్ చేసుకుంటాము, S of n అనేది n is equals to k కి నిజం అనుకొనినా. ఫ్రమ్ ద గివెన్ స్టేట్మెంట్, ఇచ్చిన ప్రవచనం నుండి S of n is equals to put k, n is equals k, S of k 1 square plus of 1 square plus 2 square plus 1 square plus 2 square plus 3 square, okay, plus so on, plus n is equals to k, k into k plus 1 into 2k plus 1 by 6 is equals to RHS also, n is equals to k, k into k plus 1 whole square into n plus 2, that is k plus 2 by 12. Let it equation number 1. S of n అనేది n is equals k కి నిజం అనుకొని ఇచ్చిన స్టేట్మెంట్లో n is equals k ను LHS మరియు RHS లలో ప్రతిక్షేపించగా we get an equation, that is equation number 1. Step 3 is we prove that S of n is true for n is equals to k plus 1, n is equals to k plus 1 it is enough to show k plus 1కి నిజమని చూపాలి అంటే ఏమని నిరూపించాలి? It is enough to show S of the given statement. We write n is equals to k plus 1. Then it becomes S of k plus 1, 1 square plus 1 square plus 2 square plus 1 square plus 2 square plus 3 square plus so on plus n is equals to k plus 1. Then we get k plus 1 into k plus 1 plus 1 into 2 into k plus 1 plus 1 by 6 is equals to RHS of the given statement. Here also we have to substitute n is equals k plus 1. n is equals k plus 1ని RHSలో ప్రతిక్షేపించినట్లయితే ఏ వాల్యూ వస్తుందో అది మనకి నిరూపణ అవుతుంది. k plus 1 into k plus 1 plus 1 whole square to k plus 2 by 12. k plus 1 into k plus 1 plus 1 whole square into k plus 1 plus 2. k plus 1 plus 2 by 12. ఇది మనకి రావాల్సినటువంటి వాల్యూ. టు ప్రూవ్ దిస్ LHS of S of k plus 1, S of k plus 1, 1 square, same value once again, 1 square plus 2 square, 1 square plus 2 square plus 3 square plus so on plus from equation number 1 by adding k plus 1th term on both sides, k into k plus 1 into 2k plus 1 by 6 plus k plus 1th term, that is k plus 1 into k plus 2 into 2k plus 2 plus 1. So I write directly 2k plus 3 by 6. K plus 1th term is here, k plus 1 into k plus 2 into 2k plus 2 plus 1, that is 2k plus 3 by 6 is equals to, here also RHS of equation 1, k into k plus 1 whole square into k plus 2 by 12 plus adding the k plus 1th term, once again same value, k plus 1 into k plus 2 into 2k plus 3 by 6. So how can, since adding k plus 1th term, k plus 1th term on both sides of equation 1, adding k plus 1th term on both sides of equation 1 అలా యాడ్ చేసినట్లయితే ఈ స్టెప్ని పొందవచ్చు. సో ఇందులో సింప్లిఫికేషన్ పార్ట్ ఆన్ ఆర్హెచ్ఎస్ని సింప్లిఫై చేసినట్లయితే, లెట్ వి అబ్జర్వ్ దర్ ఎగ్జిస్ట్ ఎనీ కామన్ వాల్యూ ఏమైనా ఉన్నదా? k ఇంటూ k plus 1 whole square, k plus 2 by 12, k plus 1, k plus 2, 2k plus 3 by 6. Common value is k plus 1 into k plus 2, k plus 1 into k plus 2 by 6. k plus 1 into k plus 2 by 6. K plus 1 into K plus 2 by 6. Then the remaining values are, ఈ టర్మ్ నుండి మనం K plus 1, K plus 2 కామన్ తీసినట్లయితే remaining values are K into K plus 1 whole square. K plus 1 common. That's why K plus 1. K into K plus 1. In the denominator also, we have taken 6 as common. So, remaining value is 2 plus here K plus 1 into K plus 2 by 6 is common. Remaining value only 2K plus 3. 2K plus 3. K plus 1 into K plus 2 by 6 into K square plus K by taking LCM. LCM is here 2. 2 into 2K plus 3. I write directly 2 into 2K plus 3. 2 to the 4K plus 2 into 3, 6. K plus 1 into K plus 2 into K square plus 5K plus 6 by 6 into 2, 12. By the factorization method, we get K plus 1 into K plus 2 కారణాంక విభజన పద్ధతి ఉపయోగించినట్లయితే K square plus 5K plus 6 can be written as K plus 2 into K plus 3. ఫ్యాక్టరైజేషన్ మెథడ్లో ఈ వాల్యూకి కారణాంకాలు K plus 2 into K plus 3 అవుతాయి by 12. Since K square plus 5K plus 6 is equals to factors K square plus 3K plus 2K plus 6. K common from the first two terms, K into K plus 3. 2 common from the next two terms, 2 into K plus 3. So then again K plus 3 common into K plus 2. These are the factors. K square plus 5K plus 6 can be expressed as K plus 3 into K plus 2 or K plus 2 into K plus 3. Finally, K plus 1 into K plus 2 whole square into K plus 3 by 12, which can be split into, దీన్ని ఇలా విభజించి రాయొచ్చు అంటే K plus 1 into K plus 2 can be written as K plus 1 plus 1, K plus 1 plus 1 whole square into K plus 3 can be written as K plus 1 plus 2, K plus 1 plus 2 by 12. ఇంత ముందుగానే చెప్పడం జరిగింది. ఇట్ ఈజ్ ఎనఫ్ టు షో, ఏమని నిరూపించాలి అంటే K plus 1 into K plus 1 plus 1 whole square into K plus 1 plus 2 by 12. మనకి నిరూపణ కంప్లీట్ కావాలంటే ఈ వాల్యూ రావాలి అని చెప్పుకున్నాం. సో ఈ సింప్లిఫికేషన్ పార్ట్లో K plus 1 into K plus 2 whole square into K plus 3 by 12గా రావడం జరిగింది. అగైన్ వి స్ప్లిట్ ఇంటూ, దీన్ని ఇంకా ఎలా విడగొట్టాము అంటే K plus 1 as it is, K plus 2 that can be written as K plus 1 plus 1, K plus 1 plus 1 whole square. Next K plus 3 split into K plus 1 plus 2, K plus 1 plus 2 by 12. Therefore, S of n is true for all n belongs to n.